Jnanam paramam dhyayam. Knowledge is supreme.
You can also define addition. So, what will be addition? That is entry wise addition. So, given two matrices A and B, if A is IAIJ, B is BIJ, order is same M cross N. So, addition will be AIJ plus BIJ. So, ijth entry of the sum is the sum of the ijth entries of the corresponding matrices. So, multiplication of matrices, for example, here when you do A plus B is same as B plus A. A matrix A plus a matrix B is equal to B plus A, right. It is a nice property like numbers, right. A plus B plus C is same as A plus B plus C, associative property, commutative property, associative property, and so on. For example, you can take the matrix to be all entries as 0, then what is A plus, you could call that a 0 matrix. So, what is A plus the 0 matrix? That is again A. So, 0 acts like an identity. So, properties similar to that of number addition are appearing with this kind of addition, right. So, we would like to define some multiplication where some nice properties come up. Okay. Let us just look at one simple operation called the transpose of a matrix. Okay. So, what is the transpose of a matrix? If a matrix is M cross N, transpose is just interchange the rows with the columns. Whatever was the first row, make it the first column of another matrix. So, define a new matrix, first row from here becomes the first column, and similarly other are replaced. All the rows become columns and all columns naturally will become rows, right. So, if it was M cross N, what is the new matrix? N cross M, right, rows have been in. So, one can write the new matrix, if you want to write the RSth element, that is A SR, interchange the row with the column. So, that is the transpose. So, simple examples for this is the transpose. First row is 5 minus 8 1 4 0 0. So, that is so this row has become a column here, this row has become a column here. So, here are some simple observations. Transpose is a well defined matrix, right. We given the all the entries of. If A is M cross N, obviously A transpose is N cross M. And what is transpose of transpose? You are getting back the matrix, you interchange rows with columns, you again interchange, right, rows of that with columns, you will get back the matrix. So, A transpose is equal to A, right. So, these are elementary properties of matrices. So, we looked at what is defined as the transpose. So, we will call a matrix to be symmetric if A is equal to A transpose, if the interchange of rows and columns does not change the matrix, right, and we will call it as anti-symmetric or normally called skew symmetric if it is minus of the A transpose. Does it put any condition on the matrix A? If I say a matrix A is symmetric, does it put any condition? Yes, because transpose will change rows to columns. So, if A was M cross N, transpose becomes N cross M, and if they have to be equal, that means M has to be equal to N, otherwise they are not equal from the equality of matrices. So, the concept of symmetric or skew symmetric matrices is defined only for square matrices. Okay. So, that is one. So, here is now the matrix multiplication. So, we have got two matrices AJK and another matrix is BKL. So, here observe here is M cross N and B is N cross P. Okay. Then the product of these two matrices AB, right, is a new matrix, let us call it a C. So, how do I describe C? So, I have to tell you what are the entries of C, right. So, let us look at the entry CJL. Okay. jth row, lth column. So, it is defined as you take ajk, you take bkl. So, when you take ajk, j is fixed, k is varying. So, what is happening? What is changing here in ajk when k varies? Jth row, kth column. So, you are taking that jth row, entries of that, right. And what is bkl? L is fixed, k is varying. So, what is that? That is the lth column, right. So, multiply the two, add up, you get CJL. So, row of the first one, column of the second, the corresponding entries you multiply and add. That naturally puts the condition that the number of columns here should be same as number of rows in the other. That is why you have put m cross n and n cross p. The number of, right, the columns here is same as the number of rows there. So, m cross n. So, what will be the resulting matrix? The resulting matrix, this is summed up. So, CJL, j varies 1 to m, L varies from 1 to p. So, that gives you a matrix of the order is m cross n A, n cross p, that is the matrix B. This n, each entry is getting multiplied and added it up, you will get m cross p, order of the product, right. It looks a very artificial way of defining the multiplication, looks a very artificial way of defining multiplication, but later on we will see that this is the way it should be defined to have nice properties, right. We will link it with what are called linear transformations. Like in functions, you have got composition of functions. Later on, we will define what is called a linear transformation, and composition of linear transformations will correspond to matrix multiplications. So, we will tie up a bit later, okay. But present you have to just remember that way, right. So, this is the matrix multiplication, okay. So, for the matrix A, take the jth row, take the corresponding column, lth column, you are looking at JL. So, jth row, lth column, multiply. So, this multiplied by B1L plus so on, add up, you get CJL, the jth row, lth column entry for the product. One obvious way of saying that it is a nice property is that it is associative. A multiplied by B multiplied by C, A multiplied by BC is same as AB multiplied by C. This way defining a product has got a nice property, it is associative. Okay. It is not commutative, A into B need not be equal to B into A, right. One can give examples for that. So, if you want to define A, B, C, right, what should be A? The order of A, B should match, number of rows here should match with number of columns there, the number of rows with B match should match with the number of columns. So, that is why you see the condition is put A is m cross n, B is n cross P and C is P cross Q. So, n this match here and P matches here. So, the resulting matrix will be of the order of m cross Q, right, that will be the order of the matrix. So, this is the property. This will not prove it, but you can try to write a proof yourself, right, and you can try to verify it for some simple examples. Product transpose is same as transpose inverted product, right. AB transpose is same as B transpose multiplied by A transpose. One reason that this should be so, because if you take AB and transpose, the rows are going to be interchanged with columns. So, similarly, if you have B transpose, already rows are interchanged with columns, rows are interchanged with columns. So, the remaining thing product will have rows and columns already matching. Okay. So, but try to verify it, try to write a proof of this if possible. Those of you who are very keen, take A to be Aij, B to be some BKL, so that A into B is defined. Now, right, if A into B is defined, then B transpose A transpose is automatically defined. is that so? Check it. Okay. So, for example, here in this example you can look at, want to verify this, okay, write down as an exercise and verify for this, okay, at your leisure, that 401 926 and this. So, that means you have to calculate AB, calculate AB transpose, calculate B transpose, calculate A transpose, product of that should come out to be equal. Okay. Right. So, this is a system I have written it on. So, look at the system. So, as I said, the coefficients are not really important, right. So, let us forget the coefficients, right. Forget the variables and the operations on them. So, what I will get? I will get a matrix which looks like A11, A12, A1 n, second will be A21, A22, from here A22, A2n, and we will have A M1, A M2, A Mn, and on the right hand side to write that one we will put it as B1, B2 and Bn. So, all the data about the system is captured in these numbers, right. Let us try to write this slightly more neatly, okay, so that we get our system. So, let us, this part of the data I will call it as a matrix A, I will call this as B. Okay. So, what is the order of A? That is m cross n, right. What is the order of B? N cross 1, and what are the variables? x1, x2, xn. So, let us write them as a column vector. So, what is the order of that? N cross 1, right. So, to get this equations, let us compute what is Ax equal to B, where this is B and this is called x, matrix multiplication, right. So, what we are doing is we are trying to calculate that. So, when I multiply, what will be A11 x1 plus A12 x2 dot 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 will be equal to B1. So, that will be my first equation, right. Is it clear? So, when I write this as a matrix multiplication, this is m cross n, A is m cross n, x is, right, n cross 1, I will get m cross 1. Okay. So, all the data, the equation can be represented as Ax is equal to B. So, this is a matrix representation of the system of linear equations. So, we call a system m cross n, right, a system, instead of writing m cross n, of m linear equations in n variables can be represented at a matrix equation A x equal to B, where what is A? A is the matrix, which are the coefficients coming in front of the variables, right. X is the variable, unknown quantity we want to solve, and B is the vector on the right hand side, right. So, that is the matrix equation, and this is actually equality, because when you multiply, right, the first, when you multiply you get the first equation, second entry as the second equation, third entry as the third equation. Equality of matrices give you all the system, right. So, the problem is how to solve this system of linear equations, and the Gauss elimination method that we have just now seen, it says you can do those 3 operations, that does not change the system of equations, right, solution for the system. What was those? You can interchange, you can replace the position of the equation. That means what? In this matrix multiplication, what are you going to do? Changing the order of equation, that means interchanging the position of one of the rows, interchange of rows, that should not affect the solution, right, that does not actually affect the solution. What is the second? You can multiply any row by a non-zero scalar, that does not change the solution, right. And third, you can add any 2 rows if you like, right, the solution does not change. So, you will get a new system which is equivalent to the earlier one and the solution does not change. And the idea is that this matrix which is representing, right, it should have lesser number of coefficients coming, more zeros coming, so that you are able to solve the system very easily, right. So, we will see it next time on this Gauss elimination substitution method for a general system of linear equations, right.